Hardly. So Docker is basically a story about a mail. For sure, anyone. Internet is back. Am I audible? Or I need to. But what you're saying? Everybody is able to hear me. Go down. How about now? More problem. Is this fine? All right. Good afternoon and welcome to this week's talk. Today we'll be talking about Docker. So, without much further ado, I'll move to the agenda for today. We'll be going through some problem statements which we face day in and day out for our development cycle, our processes which we follow, and then we'll see what is Docker, the architecture of Docker, and then I'll be moving to a demo. So, and then I'll be summarizing it, and then I'll be taking questions as time runs. So I'll start off the problem statement with a question to all of you. So what's the most cliched line a developer tells to test or to test? Sorry, sir? The other one. What was the last conversation? Have you ever said to a tester that it was working for my machine or working on yours? I don't know, man, what happened? Something happened, right? So what do you think? What basically happens? What happens that something which is working on one machine does not work on some other machine? Hmm? What? Something like that. So basically, you are writing code, you are building the code, you are deploying the code, the same manner. but something goes wrong. So what goes wrong is that basically your environment are not in sync. Some configuration files are missing, or maybe you just didn't check in the code, which is then up to you. So apart from that, what about production works? Who likes production works? No one? They have fun. They bring the team together. Right? But they are a very real thing, right? We face production bugs. So what do you do in case of production bug? You have to replicate the environment, but you can't really debug the live production side. You can't do that. Then, how do you like it when you are in the middle of the sprint, you're working on something, and then some additional requirement? You have to accommodate that thing within the same timelines. You try to do that, but you end up extending the timelines because it's sometimes it's really not possible. Sometimes the changes are very huge. There are very fundamental changes that basically does not agree with whatever changes you have already done. So these are basically the problems which Docker tries to solve, and it solves it very elegantly, and it's not actually trying to target these things. So what is Docker? One more question to all of you. So what comes into your mind when you hear the word Docker? Have you heard the word Docker? Transportation, shipping. So this is what Docker is about. So what the team at Docker we are trying to solve is the problem of shipping the application, packaging the application, so that whenever you're running it on some other machine, when you're shipping it to some other environment, it's working faithfully. It's not doing weird stuff. It's running exactly like it was running on your machine. Docker uses a technology or a concept of operating system called containers. Container again is a word very specific to the shipping industry, but then the container which Docker uses is not a concept which was introduced by Docker. It has already been here. It is existing from over a decade now. So what container is basically containers allows you to run number of processes isolated from each other using the same kernel of your operating system. That's what kernels do. Docker uses container for virtualization for sandbox, and it basically uses the kernel of your local machine. Why Docker is important for us is Docker started off as an open source project, but now from past 1.5 years, Microsoft has been working very closely with the Docker team, and for Windows Server 2016, they have introduced the native support. Also, Visual Studio 2017 has support for Docker, so which you'll see in the demo that there is some stuff specific to Docker that you have to do in case if you want to use it. So Visual Studio has simplified that stuff. Moving to the architecture of Docker, so Docker is a very simple architecture, very similar to that of Git, which we are all used to of. So Docker has a client, which is the CLI tool which you or I as a developer interact with. Docker then has a Docker host. These two components interact using REST calls, so which basically means that you can install your Docker host either on the same machine or a distributed environment. It really doesn't matter. Docker daemon is the actual background service which runs, which basically does all the heavy lifting. It is basically maintaining your images, your containers, resource allocation. Everything is done by the Docker team. So the flow goes like this. If you, let's say you want to run Windows Server 2016, so you will send a request from Docker client, Docker run Windows SQL Server 2000, Windows Server 2016. That request will go to the Docker daemon via REST calls. Docker daemon will look for that image. It will check in its local repository if the Windows Server image is present or not. If the image is present, then it will instantly create a container for you. So it's like a whole operating system booting up in a matter of seconds, or not even, it will take 1 or 2 seconds. Suppose you want to use Windows SQL Server 2016, you don't have that in your local machine, local repository. In that case, if you're sending that request to the daemon, the Docker daemon will go to the Docker registry, which is now known as Docker Hub. It will look for that image. If it will find that image, it will pull that image to your local repository on a Docker host. Basically, it's your Docker host is your machine. You are maintaining this thing. Then it will instantiate that image, and you'll be having a copy of whatever operating system that image is using, and at the top of that, you'll be having SQL Server 2016 with all the features that you want. Now, I will like to demo you what we have done. Okay. So, as part of this demo, we'll see how to create Docker files. Docker files are basically a set of instructions which are required when you want to create an image. So, the example which I gave you previously, if you want to install SQL Server, you have a Windows Server 2016 image which is provided by Microsoft, but it has nothing. It's a very plain image. There's also an image for Windows Nano Server. You can check what's that. So these images are not having anything. So if you want to actually start your development, you need to install builds, right? You need to install SQL Server, you need to install your analysis service, everything. So for that, we need to have, we write these Docker files, which are sets of instructions with install serve at the top of your image. Then we'll be seeing how to run a container. So creating an image is just part of it. It's like setting up your server, right? But to actually use that image for your development process, you need to instantiate some containers, and then we'll be seeing how to interact with the containers from the outside world, because these containers are very local to your host machine. You don't want that, right? You want to be able to interact with it from your local machine or from some other VM you're logged into. So this command Docker images, what it does is it basically will list down all the images which are present in your local repository. So I already have this Windows Server Core image, which is for Server 2016. I have this image. Then I'm moving to a folder in my virtual machine. This folder SQL. Okay, so in my U drive, I have all this stuff. Just a sec. I have a SQL Server 2016 installer, the whole installer present there. Then I have this database. So after installing the database server, I want to attach a database file to that server so that I can actually check if it's really up and running. Then the Docker file, which I just talked about. So we'll see how to write this Docker file. Okay, so as you can see, I'm telling that from Microsoft / Windows Server Core. So what this does is basically I'm telling that please use this image. If you have this image in the local repository, well and good. If you don't have this image, Docker daemon will pull that image from the Docker. Okay. Then I have specified myself as the maintainer. I have specified some environment variables which I'll be using later. I've also specified that I want to copy all the files in my current directory. So as you see, I have my SQL Server installer, my database file. So I've specified all that stuff. Yeah. So I want all this to be copied to my container. Now these two run commands, basically after having that image, I want to install SQL Server on top of it. Now as there is no GUI, I have to use command line. So that's why I have written this statement. What it does is basically it will install SQL Server. I have provided the name for the instance. I have also specified what all features I need to install. So I have specified SQL Engine and integration service. And then this PowerShell command, what it does is it sets up the port and everything. And apart from that, at the bottom, if you can see, there's a command statement, CMD. So what I'm doing here is I'm saying that after all of this is done, when you're actually instantiating a container, please run this command. This PowerShell command, use this start file, provide these parameters. So this is the file which will be executed. This command is executed every time you instantiate a container without specifying what process you want to run on that container. So what this does is it will set up the service account password, whatever password I specify, and it will attach a database if I'm specifying any databases. I'm moving to the U drive, I'm moving to the Docker folder because I don't want to use absolute paths. Now I'm telling Docker to build that image for me. So there are a lot of flags which you can use. You can go to the documentation for that. But I've used just the necessary flags. So I just want to specify a name for the image which I'm creating. So with this, what Docker will do is, I already have a SQL Server core image. It will only be doing some additional stuff on top of that. It will create one more image with this name, Windows Server Core 16. Now that dot at the end is basically for specifying the path of the Docker file. Since we are already in the directory, I don't need to specify the path there. Now it will execute all of the commands. It will pull the image. Since the image was already there, I don't need to download the image. It will install SQL Server. It will fire those PowerShell commands which I have specified to modify the registry. And once this is done, I have created my image. That's just part of the job. Now what I need to do next is I need to run a container so that I'll be able to use the SQL Server instance which I've just installed. So this is the command for that, docker run. Then I'm specifying a flag D. What does is that it will run the container as a service. It will be running in the background. I won't be interacting with it, but it will be there as a service. Secondly, one more important thing is the P flag. What I'm doing is I'm mapping the port 1433 of my container on which the SQL service is to the port 8008 of my host machine, so that from the outside world I'm able to interact with the container. Then I'm specifying a password for the service account. I'm also attaching a database. I specified the name of the file, and at the end I've specified the image which I want to instantiate as a container. This is the image which we created previously. So once this is done, as soon as I hit enter, container will be fired. So as soon as you see this means that the container is up and running. So a whole SQL Server with the Windows has booted up, and I can do it multiple times. And all those containers will be very isolated of each other. That means if I'm running two such containers, let's say delete this database file on one of the containers, will still be accessible on the second container. And obviously, none of this will affect anything on the host machine. Now what I'm doing. So containers are is a feature which is provided by Windows, and Linux. Containers allows you to run process like let's say you're running command prompt. Okay, you can run two command prompts on two containers, and those will be very isolated of each other. Though they won't be interacting with each other in any way unless you want them. So Docker has not introduced this container anymore. Yes, it's possible. If you want to. Okay, so this command docker ps, it basically tells you if what all containers are running in your system. So as I told you, I can fire up 4 or 5 containers. So it will list down all of those. All those containers will be having a unique ID. Also, I have an option to specify name to a container if I want to. Now, what I'm doing is I'm moving out of from my this host machine is basically a remote server. I'm moving out of that. I'm coming to my local machine, and I'm trying to connect to this. Now, as you see, I've specified an IP address there. So that IP address is of this host machine, this virtual machine, this server which I'm remoting. So this IP is the same IP address which I've used here. Apart from that, you can also observe that I've specified the port number 8008 since we have mapped these ports. Okay? And I'm specifying the instance name here. I'll be specifying the same password which I provided there when I was running the container. And as you can see, I should be able to connect, right? And you can see that it's SQL Server 2016 latest version. And I can do anything which I can do with a regular database. And if I fire up 2 or 3 of these, those 2 or 3 containers will be isolated. Nothing. I mean, if I delete some table from this one, it won't affect that, the other container. So it's just a select query to verify that it's actually working. Right. So to summarize all of this, what you so you've seen what Docker can do. One thing which I could have mentioned earlier, I didn't do so, is you can set up your servers very quickly. Uh, can anybody tell how long will it take to set up a server, install everything from scratch? Who has done it recently? And you'll be doing the same activity over and over. I mean, you'll be installing some stuff once, but you'll be doing it over and over again. Multiply by the number of machines that you have. So you can eliminate all that tedious activity. You will have to write a Docker file, and you can instantiate, let's say, 5 containers if you want. You can save time and cost, definitely. So right now we are using these Azure VMs. These are very costly. If instead of using 5, we can have 1 with more configuration, and we can fire up any number of containers. Okay? Then you can scale very quickly, which means that for some ad hoc requirement, if it comes, I can fire up a new container. I don't have to compromise my work. I don't have to adjust something. Right? The cons is basically there's a learning curve involved. Right? You will have to know how to create Docker files. You will have to know how to deal with the Docker file, how you will install things to the container. You will have to work around that. Then there is no GUI. At least no native support for GUI. There are some third-party tools which you can use, but natively Docker has no GUI. Questions?
So basically, instead of processes, we are creating the whole environment, new environment on our host, right? That could also be consuming some portion of.
Yes, but as opposed to virtual machine, it takes less resources. Why? Because it is using the same kernel. So you are having same kernel, right? It will be using the same kernel, and what you can see is if you open a task manager, you will see that all the processes which you are firing on the container will be visible there. But if you fire up a task manager somehow, because there is a GUI, if you list down the processes, you will not see the host processes there. So it is using the same kernel. What virtual machine does is basically you will be having a layer of hypervisor and it will abstract everything down there. If you're having 4 or 5 virtual machines, you will have to allocate RAM to each one of them. Since you're using the same kernel, if you are having 2-3 processes, the process which requires more resources will be allocated. And you don't have to worry about allocating resources explicitly, as you have to do in case of virtual machine.
So does it mean we cannot use this on virtual machine?
Yes, you can use it on top of the virtual machine. So let's say, as I told you, it's using the same kernel, which basically means if you're running a Windows machine, you can't use a Linux image. But if you're having a virtual machine, you can install Linux on that and you can create containers on top of that. In that case, it will provide. I mean, so most of the base images are present, but yeah, there could be a case that something newer comes and the image is not available there. It could be a case.
But always most of the time we work in a Microsoft environment, and we can have the switch to that which is that's written and open.
So will be
very loud. Can you give the mic?
So what I ask is, most of the time we work in a project under Microsoft environment. So is there a script where something where once this machine gets set up, after that machine is ready, we can move that machine into corporate environment. you can directly set up in the corporate environment, right? You can have a virtual machine there.
The thing is, as soon as we create the first machine, the first time that was possible that it gets started, it's in a workgroup. It will not go into a domain directly. It will be a workgroup. I'm talking about how can I move that into a domain? Is there a way by the script that I can make it to be a domain or anything? Or I have to do
You
it?
can, what you can do is you can access anything which you're creating within the corporate, right? So you don't have to worry about moving into the domain. Instead of that, you can create it within the domain. Right?
Yeah. So just to elaborate more, the you have a host VM. The machine that you're going to create is not a new machine that is getting created as such. You are isolating a set of processes from the host VM and calling that as a new VM. So now let's say I have a AZ box. Okay, so now I have a physical machine that I've got from Microsoft. On that I have multiple VMs that I have hosted using Hyper-V. On top of the Hyper-V, I will install Docker. Docker will instantiate containers. Containers are using processes from the host VM. So if the host VM is in the Redmond domain, that means Docker containers are automatically in the Redmond domain. This one I want to do. And if you want to copy one image from one host to another, you can commit that image and you can directly download it on the other machine. It's like a Git repository. You can commit a VM image and download it over there. Another alternative that you showed right now was spinning up a VM using a script. So if you saw that script, so I'm answering the question. So if you saw that script, it was using Windows Server 2016, which we had downloaded from the Git repository, and then you was installing SQL Server into that. So if there is something that is not available, you can download a Windows Server and install whatever you want on top of it.
Separate time is few seconds or something.
The instantiating time is good. So when you're building the image, it will take some time.
It's only one time.
Yeah, but it's not.
If you already have the entity already has a VM, which has everything configured, which is your and we assume there is a client machine which has and the client in the whole. Can the entity be set up when new user machine using this one?
Exactly. You cannot set up a new machine as so it doesn't have a GUI. We are ready with
the control.
it doesn't have a GUI. So it's basically working in DOS. If you have a readiness of if it's working in DOS, then you can probably use it.
So actually, I mean, while installing SQL Server, I had to use the command line interface, right? I was specifying parameters to pass to that installer setup file. So using that CLI language, you can use it. So if you want to install, let's say, Visual Studio, you will have to go by that route.
I was just thinking, for example, that I want to replicate the RM or website in government domain. Right now, we deployed a database. You can do that. Deploy a website on this.
Yes.
Yes, so you can deploy. So there is a IIS. So this is a Windows Server kernel. You can enable IIS within that kernel, and you can create a website using commands on IIS. And from so you will be something like you're developing on your local machine, and you are deploying using a package to a remote machine. Similarly, you develop the host machine, and you deploy the package to the container.
So both are even and we are creating a storage in a container on the host machine. What kind of machine can replicate that on the host machine?
So even if you delete all the registries, system 32, everything, on a container, on the host machine will be intact.
Primarily trying to reduce the server setup time. When you go from what you do right now is we set up a dev machine, then we build a couple of cases, we set up a test machine, then a prod machine, then we realize that we wish to install one library because of which we go to investigate them. Instead of that, we use this that has
The required resources will be less in fact in this, but what was the zone comparison compare like from running in isolation on Docker against more virtual machines. So, maybe more equal or it will be relatively equal.
So it will depend on number of processes which are running within the container. So if you're using a virtual machine, that means you will be using a host OS, right? That means you'll be taking up that space, and you will be running all the services, all the processes which runs when your machine boots up, right? But in case of Docker, all those processes are already up, right? You just need to, let's say, if I want to run a web API on one container, on another container I want to host my SQL server, and on the third container I'm using my web application. Basically, that's if all the things are working inside. I can isolate those things separately, right? If I'll be using three virtual machines, I'll be in anyways, more resources will be required in that.
It will be only because you want. Because if you're host 3 VMs on let's say my HTTP of RAM, and you're hosting the application on
Can't.
is there a way to
Yes. So you can, I mean, you don't have to do it explicitly, but you can. You can also configure containers to talk to each other, which they don't. So I've been repeating that containers are isolated. They are very isolated of each other. But if you're using a web API, right? I told you that you're using one more container for SQL Server. You need them to be able to connect to talk to each other. These are something that you can do.
with the resources?
Yeah.
If you mentioned the support in PS27.
Yes. So basically, I told you that I have to write a talk of it. So these are something which Visual Studio helps you with. It won't do the whole thing.
There are few I develop it. I deploy it to Docker and we create a control on my machine.
I'm not sure.
We can check it.
Thank you. Yeah, if you have any questions, you can contact me or
Like,